In the last lecture, we learned how to read a data file and then extract a sub part of that data and then write it back to another file. Now, once I get a data set for analysis, I may have to go for detailed statistical analysis, or I may have to do some analysis to understand the different features of the data. Before we go for such detailed analysis, most of the time what we do, we look into the generalized behavior of the data, generalized properties, overall properties of the data. That means, we want to look the general statistics of the data. For example, you want to know the mean of different variables, the variances of those, how the data is distributed, like that. So, these are in general called descriptive statistics. So, once you have got the data using R, you can actually calculate these descriptive statistics for your data set, and then you may make some certain decision to how to analyze the data further. So, in this lecture, I will discuss some of the descriptive statistics that you can perform using R. I will be using R Studio, you can use native R also. To show the utility of R to get descriptive statistics of a data set, I will create a data set for a blood pressure experiment. Suppose I have multiple volunteers and I have measured their blood pressure, right, and I know their age and I know their systolic pressure, I know their diastolic pressure. In the last lecture, we have learned how to read a data file, but here what I will do, suppose you have written me the data in a paper and I want to create the data set in R itself, right. So, let us start doing that. The first thing that I have to do, I have to prepare the data. So, I have manually suppose entered that the ages is a variable, and the ages of different person in my data set. Someone has 23, that another person has the age 34 years, somebody has 42, something like that. So, I use the C function here, C function to join them together to create a vector, and I give the name of that vector as ages, right. So, let me execute that. So, you in the environment pane you can see a ages variable has been created. It is a numerical variable and it has 10 elements, 10 data points, and those are 23, 34, something like that. Similarly, for systolic blood pressure, for each of these individual, I sequentially arrange them and then use C function to create a vector called sys. Right. So, again I am using C function, and within the round bracket or the first bracket I am putting the corresponding value. Remember what I have done, this 122, which is the systolic pressure for the person who is the first person in my ages list also, right. That order I am maintained. And then similarly, diastolic pressure is a variable, dia is also created using the C function, where I have joined all these diastolic pressure of each of these individual to create a vector. So, let us execute both of these. So, now I have three variables, ages, dia and sys. These are the age, diastolic pressure and systolic pressure for individual, and I have these three vectors, and now this is my raw data. Now, on these raw data I can calculate certain descriptive statistics, right. So, let us start with something which usually many a time you have to calculate first, that what is the size of your data set. In this case, we know that there are only 10 people who have 10 samples, but sometimes your data set can be very large, right. So, how do I know how many samples are there in that? The option to do that is to use something called length function. So, length function, length written here, and in the round bracket you have to write the name of the variable. In this case I have written sys, this is the variable for systolic blood pressure. So, the length will tell me the length of the vector. Sys is a vector, right, it is a list, it has some 10 numbers in that. So, if I use length function to get the length of this variable sys, I should get something like this 10 here. So, it has 10 elements in this or 10 data points in this sys variable. Now, once I have got that, I may ask what is the minimum value of systolic pressure, what is the maximum value of systolic pressure, like those questions, right. So, those are also part of descriptive statistics. So, to get the minimum systolic pressure of these samples, I have 10 samples and I want to get the minimum systolic pressure out of those, I will use the min function, that will give me the minimum number, of the variable cis, right, because I am bothered about the systolic blood pressure right now. So, similarly, if I want to calculate the maximum of these values, I will use the max function, and again I am working on the cis variable. So, here I execute that, and the R says the minimum value is 115, quite good enough, because on an average it should be around 120 or something less than 120, and the maximum value is say 131. Now, I have calculated the minimum and maximum for systolic blood pressure. You can also use this mean and max function to get the minimum age of the samples, minimum maximum age of the people in your sample. You can use the same mean max function to get the minimum value for the diastolic pressure as well as the maximum value for the diastolic pressure. I have not shown them, but you can easily do that. Now, few other statistics that are very useful to understand the dispersion of the data and the behavior of the data you must be knowing is the minimum, median, variance, standard deviation, all these things, and I am sure you know the definition of all those. So, how can I calculate median, mean, variance, sum of these suppose systolic data? So, here I show that. So, to calculate the median, I will use median function, as it is shown here, median, then inside the round bracket I write the name of the variable. In this case I have written cis, and to calculate mean, that is the arithmetic mean or the average in colloquial word, it will be mean, the function is called mean, and again I am using over the variable cis. So, let me calculate the median and mean. So, I execute the median function on cis. So, it says the median value of systolic blood pressure in my 10 samples, 10 people is 120, whereas the mean is, it says 121.3, right. So, they are different. Now, I have calculated the mean. So, obviously, I will be tempted to calculate the variance of the systolic data, blood pressure data, right. It is very easy to calculate. R has an inbuilt function called var, which will be able to calculate the variance, and the argument for this function will be obviously the variable for which you are calculating the variance. So, I call var function for cis, and the variance is 29.56, something like that. So, once I have got the variance, obviously I can get the square root of that. You can use the square root function that we have discussed earlier in one of the lecture, or you can use the exponent operator to get the square root, but R has inbuilt standard deviation function also. So, that is called SD function, SD, as I have shown here. So, I will use that with the argument, because I want to calculate the standard deviation for systolic blood pressure data. So, the argument will be the cis variable. So, that is what I do. So, the standard deviation is 5.437524. So, what I have done, I have calculated the mean, median, variance and all these things. Now, you may be wondering that isn't there a way that I can actually get all these general statistics, which are very handy in data analysis, for all these 3 variables. I have 3 variables in my data, right. One is ages of each of these individual, then their systolic blood pressure and their diastolic blood pressure. Can't I somehow get the statistics, the descriptive statistics of all these 3 variables by just one stroke? Yes, I can get that, but to do that I have to create a table, right. So, in Excel you may have created table where in this case you will have the first column may be ages, second column may be systolic blood pressure for individual, and the third may be the diastolic pressure. So, I will create a table in R using this variable ages, dia and cis. So, how should I proceed? What I will use a concept called data frame. Let me briefly say what is data frame. Data frame is essentially something like a table, and you must be habituated with creating table, and in Excel or any other spreadsheet software you create tables where you may arrange the data, each variable in one column, and the rows are each sample, right. So, here also we create something like that, a data type called data frame, and if you think carefully, a table is nothing but a matrix. The difference between matrix and a data frame would be, in matrix, if I create a matrix, 2-dimensional matrix with suppose 10 row, 3 variable, then all the elements in that matrix must be of same type, either they are integer or they are real number or they are character, something like that. You cannot mix them up. Whereas when I create a table type structure using data frame, each column can have their own data type. So, I can have one column where only characters name will be there, whereas I can have another column where I may have numerical values like integers. So, in this case, in this problem, what I want to create? I want to create a table or data frame using the data frame function. The function itself is called data.frame, right? And I will pass this variable. I have 3 variable in the environment section. You can see I have 3 variable ages, dia and cis. I will pass these 3 as arguments to this data frame function, data.frame function, to create a table with columns corresponding to each of these variables, right. Let me do it, it will be easy to understand what we are doing. So, what I am using, the function that I am using is data.frame as it is written here, and the arguments are the name of the variables. I have 3 variable ages, cis and dia. So, those 3 arguments are comma separated and given inside the round bracket, and this whole output of this function is assigned to a variable which I have named as blood pressure data, bp.data, fine. So, let me execute that. Now, look into the environment section. I have a new data type has come, it is bp.data, it is a variable, and it is saying it has 10 observation and 3 variable. So, let me open this, double click it, and I can see the data here. See, I have got what I wanted. I have now a table with the first column having the ages data, age of individual, and then the second column and third column gives me the systolic and diastolic pressure for individual of them, right. So, I have got the table the way I wanted. Now, I want to extract the statistics, the descriptive statistic, mean, variance, something like that for this whole thing, fine. So, to do that, let me get back to my script. So, I have created the data. Now, what I will do? I will get the statistics of that. So, to get the statistics, I will use the very handy function, useful function called summary. So, if I call this function and if I use this bp.data as the argument, then it will give me the summary of this particular table or data frame, right. So, let me execute it. Here you can see the summary. The summary is like this. For each column, it has written the name of the column, the variable name or the header. So, I have ages, cis and dia, and then the rows are certain statistics which are very common useful. Suppose it gives the minimum value and the maximum value. For ages, the minimum value is 22. So, the youngest person in my data says has 22 years, is 22 years old, and the maximum is 42. The oldest person is 42 years old. It also reports the median and mean for all these 3 variable. For example, the median and mean for age for these people are same 32. So, this is how you can actually generate descriptive statistics, the basic information, basic statistics which are required to understand the data that I have in hand before I jump start doing some complicated analysis. There are a few other analyses that I can do, let us discuss those. So, in this example, the second example, what I will do, I will read that iris data. I have it is in CSV file, we have used that CSV file earlier. So, I will import that, I will read that CSV data and calculate the summary of that, and then also what I will do, I will calculate some basic statistics on this data, subpart of that data, and another interesting thing, I will see the distribution of that data. Let us go to that. So, the first thing what I will do, I will read the iris data, iris flower data using the read CSV function. We have done that earlier. So, read CSV will take here 2 arguments I will use. One is the name of the file, that is iris.csv within the apostrophe, and I will specify header is equal to true, and we will assign this whole thing to iris.data, a variable. So, let us read that data. So, I have read it. So, now I have a variable called iris.data, I can check it here. I have a table, that data frame I have, we will sepal length, sepal width, petal length, petal width and variety as 5 different variables, and I have 150 observation as written here in the environment section. Now, what I want to do, I want to get the statistical summary of it, descriptive statistics of that, right. So, again I will call that useful function called summary. Now, it will summarize the iris.data. So, here comes my summary. So, again each of these variable are in column and it is reporting the minimum, maximum. As you can see, the mean width of sepal width is 2, whereas the maximum sepal width is 4.4. The median is 3 for sepal width, whereas the median for petal length is 4.35. And the third column is the third variable, sorry, not the third, the last variable is variety and it has characters in it. So, you cannot have this type of statistics for this. Fine. So, I have got the summary of that, but I want to calculate the mean of a particular variable or a subset of those variable. Let us do that. So, what I will do now, I will calculate the mean petal width of only one type of flower, that is iris versicolor, right. So, there, if you remember, in this data set, iris data set, there are multiple iris flowers data are there in the one single file. So, and that is defined by the variable variety, and I want to know the mean petal width of iris versicolor, only one type of one variety of the flower, right. So, in this to do this, what I will do, I will extract only the data for the versicolor variety and then I will calculate the statistics, right. So, to do the subset of the data, I will use the subset function that we have learned earlier. So, subset will give me a subset of the whole data and it will take the arguments will for this will be iris.data is the name of the data, right. So, that is one argument, and the second argument, which is a logical argument. What I am telling it here? I am saying the variety variable must be equal to, two equal to sign is there, is logical equal. So, this equal to what? Versicolor, and versicolor is a character. So, that is why it has been written within the apostrophe. So, if I run this code, I create a new data set versi, because I have assigned this to this versi variable. So, let me open that. So, you can see now I have 50 observations and all of these are of variety versicolor, right. Because remember, I have used the variety equal to versi as a logic to extract the subset. So, I have extracted that. Now, I want to calculate the mean of the petal width of these versicolor flowers, right. So, what I will do? If I check this versicolor data, this petal width is one variable. So, I can extract that one using the dollar sign, right, dollar operator. So, that is what I am doing here. I am calling the mean function to calculate the mean. Now, the argument is versi dollar sign petal dot width. Now, petal dot width is a variable of versi data, and I am asking using this dollar sign that I want only that column, that variable, that object. So, I will want that part only, and I want to calculate the mean of that, right. So, what I am asking is that you take this petal width column only, petal width variable only, and calculate the mean of that. So, let me run that. Yes, it has calculated, and that mean I have assigned as mean PW versi. So, let me check out what will be the value of that, mean dot PW dot versi. The value is 1.326. The last thing that I want to discuss in this video is that apart from this numerical value, this basic statistics in terms of numbers, many a time I want to visually see the distribution. Because remember, sometime it may happen that in your data there are lots of outlier, right. Some sample has very high value or very low value, but your mean median may not reflect that, right. So, it is always good before you jump into any analysis, why do not you plot a frequency histogram, right. So, what I will show to you now is that how to create a frequency histogram for my data. So, what I will do, I will calculate the frequency, draw the frequency histogram for the petal width. I could do that for any other variable in my this data set, but I will do it for the petal width first. So, to do that, I will use a function called hist. Hist function will create frequency histogram by default, right. It has lots of argument by which you can actually create the histogram, but I will use the basic one, that I will give the name of the data variable to it. I will just give the data as the single argument to this hist function, and it will draw the histogram by default options, right. So, what will be my data? My original data set is iris.data, and I want to get only the petal width variable. So, I am again using the dollar sign here. So, iris.data, then I am putting this dollar operator, and then I am asking for the variable petal dot width. So, it will give me, it will take only the petal dot width variable data, and it will draw the histogram for that. So, here I get the histogram. Let me zoom it so that it will be clear for you. Using this zoom option given here, I could zoom it. You can see by default options it has drawn the histogram. So, the horizontal axis is the sepal width. I have not given any specific name, so it is just taking the name of the variable directly, and on the vertical axis I have the frequency rather than the count actually. Now, you can easily see I have a mixed population. Obviously, I have different types of different varieties of iris flower in that, and their petal width of each all of them are not similar. So, I have distinct behavior here. There are some flower which may belongs to this lower part of the histogram, whereas the other flowers may belong to this extended one, the larger one, right. So, now what I will do, I will try to calculate the histogram. I will try to draw the histogram for only the versicolor variety, suppose. So, what I will do, let me close this. I want to draw it for the versicolor. So, already I have extracted one variable which is called versi earlier, right. So, that versi has my versicolor data, and from that I want to extract only the petal width variable. So, again I will use this operator of dollar sign, and I will draw the histogram for that variable in the versicolor. So, I execute it using the same hist function with default options. Now, here again let me zoom it. I have got the histogram for the petal width of only versicolor type, versicolor variety of iris flower, and it has largely homogeneous one. You can see it is the it is bit heavy on the left hand side, and it is narrow on the higher values. This brings us to the end of this lecture. In just a brief, in this lecture we have learned how to calculate the basic statistic which we call descriptive statistics, that give us a overall feel of the data using R. Thank you for joining with me today. See you in the next one.